Myself, S. Omkar Raju. I am pursuing BTech second year in VVITU College. My roll number is 24BQ1804E0. I am telling about the topic Boolean algebra and theorem in stat STLD subject. I am choosing the contents from the Boolean algebra. Introduction, definition, basic operation, Boolean laws, Boolean theorems, applications. Introduction. What is Boolean algebra? A branch of algebra that deals with binary variables and logic operations. The variables can only have two possible values, true 1 or false 0, from of mathematical foundation of digital circuits and computer logic. They are also called as binary numbers 1 and 0. These are developed by George Boolean in the mid of 19th century. Boolean algebra plays a major key role. So we are discussing about the definition of Boolean algebra. Boolean algebra is a mathematical system closes over flower bracket of 0, 1 and binary operations plus comma into. Discussion. Basic Boolean operations. There are three operations. They are AND operation, OR operation. Basic Boolean operations. There are three operations. They are AND operations. It is denoted by multiplication. OR operation. It is denoted by symbol plus. NOT operation. It is denoted by inverted comma. Now we are discussing about the basic Boolean operations clarity and logical conjunction. The output is true only if all inputs are true. Symbol is AB or A into B. Truth table of input AB, output C. Input A0, B0, output 0. Input A0, B1, output 0. Input A1, B0, output 0. We can find them by A into B. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. Therefore, input 1, A, 1, B, 1, output C equals to 1. This is the truth table of AND gate. Now we are discussing about the another gate, OR gate. It is denoted by plus. Logical disjunction. The output is true if at least one of the input is true. Symbol is A plus B. Truth table. Let's input, output. Input are A, B, output C. Input A, B. A equal to 0, B equal to 0. Then output C equal to 0. Because A plus B, 0 plus 0 equals to 0. A equals to 0, B equal to 1. So output A plus B, 0 plus 1 equals to 1. Input A equals to 1, B equals to 0. Output A plus B, 0 plus 1, 1. Input A plus A equals to 1, B equals to 1. Output 1 plus 1, 1. Basic Boolean operations. NOT gate. Basic Boolean operations. NOT gate. Logical or negation or inversion. Inverts the input. Truth table. Input A 0. Output A 1. Input A 1. Output A 0. Now we are discussing about Boolean laws. So there are many laws. We are discussing about three. Commutative law. Commutative law. It is A plus B equals to B plus A. Suppose 1 we get suppose A equals to 1, B equals to 1. Therefore 1 plus 1 equals to 1 plus 1. Associative law. A plus of B plus C equals to A plus B plus C. or A into B bracket of B into C equals to A into B bracket into C. Distributive law. A plus B into C equals to A plus B into A plus C. Identity law. Identity law is A plus 1 equals to A. A into 1 equals to A. This is the identity law. It is used widely. Complement law. A plus A dash or A bar equals to 1. A into A dash equals to 0 or A into A bar equals to 0. The bar or dash indicates the complement of the number. Boolean algebra theorems. It states that dual expressions can be achieved by replacing positive with into and into with positive, replacing 1 with 0 and 0 with 1. This is called dual expression. In dual expression, into symbol is replaced by plus, plus symbol is replaced by into, replacing 1 with 0, 0 with 1. Properties of 0 and 1. A plus 0 equals to A. A into 1 equals to A. These are now another we discussed back. There is a identity law. Now we are using identity law. Now we are seeing exhaustion theorem. A plus A B equals to A. A into A of A plus B equals to A. This is called exhaustion theorem. Now we are discussing about combining theorem. Combining theorem is known as A into B plus A into B dash equals to A. By seeing how we can calculate this, by taking common A, B plus B dash equals to 1. We know that from the another law. A plus B of A plus B dash equals to A. By seeing A into A into B dash, A into B, B into A, B dash. B dash equals to 0. A into A equals to 0. By taking A common, there will remain A. Combining theorem. Now we are discussing about applications. Logic gate implementation. It is the foundation for designing circuits. Logic gate implementation plays a major crucial role in designing of the circuits. Using logic gates like AND, OR and NOT, we can make any gate. Now we are discussing about circuit simplification. Using Boolean theorem to simplify expression helps to reduce the number of logic gates needed, leading to more efficient, cheaper and faster circuits. Circuit simplification in that logic gates plays a major key role by leading to more efficient, cheaper and faster circuits. Designing digital system. It is used in the design of various digital components including multiplexers and demultiplexers. Yes, it is used widely in multiplexers and demultiplexers. There are multiplexers and demultiplexers. Now we are discussing about adders and subtractors. In designing digital systems, adders and subtractors plays a major crucial role. Memory elements, flops. Memory element, flip-flops. Flip-flops are memory storage elements. They are used for something. We can say that they store the memory. They store the previous output and input. They are very complex. Computer process, CPUs. In CPUs, logic gates plays a major crucial by passing the signals by 0 and 1. In CPUs, there is only the passing zeros and ones. By the following zeros and ones, the computer works. This is they are zeros and ones are also called as binary numbers. NAND gate is an universal gate. By using NAND gate, we can make AND gate, OR gate, or NOT gate. Now we are thanking you for giving me this opportunity.